Back with some geometry, chapter 7.5, properties of trapezoids and kites. Alright, so first off, let's look at some trapezoids. Trapezoid is a quadrilateral that has exactly one pair of parallel sides. So here we have an example. Within that trapezoid, we call the parallel sides bases. The non-parallel sides we refer to as legs. And then the angles of a base are called the base angles. Now, the consecutive angles on the base side. So these two would be considered base angles towards each other, or these two base angles. Right. Oh, and this right here is an isosceles trapezoid where the two legs are congruent. Okay, show that this is a trapezoid, then decide whether it's isosceles. Okay, in order to determine that it is a trapezoid, exactly one pair of sides has to be parallel. So it looks like it's going to be these two. Alright, now one way you could do it, if you have a nice graph like this, I can see up 1 over 2, up 2 over 4. Both of those have a slope of 1/2. So those would be parallel. Right, or I can do it mathematically using the slope formulas. So RS, plug in the points into your slope formula, simplify, and you get a slope of 1/2 for each, which means those two are parallel. Alright, then we'd look at the slopes of the other two sides to see, well, these two are not parallel. So therefore, only two of them are parallel, which makes it a trapezoid, because we only have one pair of parallel sides. Now next I want to determine whether it's isosceles. Okay, so in order to determine whether it's isosceles, the two legs would have to be the same length. Alright, so I'm going to find the measure of RO. Alright, I can go from 3 to 0 and find that this length right here is 3. And then I'm going to find the length of ST, and I'm going to use the distance formula for that. So I'll take the coordinates here, 2 minus 4 squared, and then 4 minus 2 squared, and that gives me 2 radical 2. 2 radical 2 is not the same as 3, therefore it is not isosceles. Okay, in an isosceles trapezoid, the base angles are congruent. So each pair of base angles is congruent. So not all of them together, but each pair. So within that side, these two to each other and these two base angles right here. And then the converse of that is, if a trapezoid has a pair of congruent base angles, then it is isosceles. And theorem 7.16, the isosceles trapezoid diagonals theorem. If it's isosceles, or it is isosceles if and only if the diagonals are congruent. Alright, using properties of isosceles trapezoids, this stone right here above the arch in this diagram is isosceles. We know that it is isosceles. They tell us that. So now we want to find measure of K. This measure right here is 85 because base angles theorem of isosceles triangles. Let's align that. Measure of angle K is 85 degrees. And then we have measure of angle M. Alright, this angle right here, well, this is on a parallel line right here. Here, these two are parallel, which makes these two angles to each other consecutive interior, which means they add up to 180. So 180 minus 85 would give me 95 for this angle down here. So angle M is 95 degrees. And then angle J, base angles theorem, is also 95 degrees. Okay. If you take the midpoints of the two legs and you connect them, you get what we call the midsegment. The cool thing about this midsegment is that it is the average of the two bases. So you take the length of the short base added to the length of the long base, divide that by 2, or multiply by a half, same thing, and you get the midsegment. So it's the average of the two bases, or 1/2 the sum of the lengths. Alright, so we want to find that. So we want to find MN, and we know that it's the midsegment, so we take 12 plus 28, and we're going to divide that by 2, which is 40 divided by 2, so that is 20. Boom. That was easy. Okay, now if I want to find the length of the midsegment here, YZ, okay, well, we're in a coordinate plane. I need to find the lengths of each of these and divide that by 2 or multiplied by a half. Okay, so distance formula, I'm going to find the length of SV. Right here, it's 2 radical 5. Distance formula, I'm going to find the length of TU, 4 radical 5. Now, I need to add these two together and then divide that by 2. So I'm going to add those two sides and then divide by 2 or multiply by a half. And that gives me the length of YZ, which is 3 radical 5. There we go. That's trapezoids. Now a kite. A kite's a quadrilateral that has two pairs of consecutive congruent sides. Okay, not opposite, but consecutive. That means one comes right next to the other. So that makes it a kite. Cool thing about a kite is that the diagonals are perpendicular to each other. Also, in a kite, the one pair of opposite angles, and it's the one in between the non-congruent sides. Those two are congruent. So, if we want to find a measure here, okay, we know that these two are not congruent, which means these two have to be congruent. So together, all of these would add to 360. So we say 2 times that measure, or we'll just say 2x plus 115 plus 73 is equal to 360. And then we can add all that up. And that's 188. Subtract that from 360. And that means 2x is equal to 172. Divide that by 2. And x is equal to 86 degrees. And so the measure of angle D is 86 degrees. Alright, here's a nice little flow chart of quadrilaterals, how they're classified, and then when you get a little more specific. So quadrilaterals are all these different shapes. These over here are all considered parallelograms. Well, this one isn't. But these here are considered parallelograms, these 4. And then you could split those up into either rectangles or here's a rhombus. Now, square is also considered a rhombus. And then more specifically, if you go to a square, it's a rhombus or a rectangle. So every one of these has a quality of the one before. Right? A square is a rectangle. Rectangle is a parallelogram. Parallelogram is a quadrilateral. Square is a rhombus. Rhombus is a parallelogram. Rhombus is a quadrilateral. Same thing with trapezoids here. Alright, identifying a quadrilateral. What's the most specific name for quadrilateral ABCD? Be careful. Pictures are not usually drawn to scale. So looking at this, it looks like a square, but do we have any information given in this shape to tell us that it's a square? Well, if it was a square, we would have to know that there's a right angle here, and it does not tell us that this is a right angle. The only thing we know is that the diagonals bisect each other. And diagonal bisector tells us that the most specific we can get with this is that it is a parallelogram. Parallelogram. We don't know that any sides are congruent. We don't know anything about the angles. So the most specific is a parallelogram. And ladies and gentlemen, that's all for today. Check in again next time for some more fun.